Hello, this is our presentation on what is the capitalist spin by Victor and Will. We hypothesized for our question that 60 to 70% of Bellarmine students know what the capitalist spin is. We got this number from an online quiz website called Sporkle, where 90 to 100% of their users know what the capitalist spin is. We decreased our number from Sporkle because their number can be biased due to the people that use the online quiz are probably more knowledgeable on the topic of capitals around the world.
Alright, so for our population, we will be using the entire student body, which is around 1,700 students. For a sample, we gathered data from 120 students from where we would consider hotspots around the campus. And we would define hotspot as an area where most students will pass through the day. So that will be the Loki drop-off, which is behind the gym and behind, like, near the long end of Loki, the front doors of Loki, the O'Donnell front doors, the Sobrato front door, the cafeteria line at Licardo, and the food truck line.
Alright, this is our data table. Our sample size is 120 students. And of those 120 students, 66 students knew what the capitalist span was, which makes it 55% of the students. And this is taken from a population of about 1,700, which is the population of Bell.
Right, before we move on to calculations, we need to check for conditions, which basically allow us to calculate. The first condition is for randomness to prevent bias. It is, however, important to note that our sampling method that we used was not completely random. It involved more of like a picky choosy thing for us because no methods of true random sampling were available to us for this experiment. The second condition is that we have to check for a normal distribution, which can be done through the equations on the slide. And we also have to check that the sample is independent of any previous samples that might have been taken, meaning that any previous samples would have no influence on the sample that we took. And we know that this condition is valid because our sample size is less than 1/10 the size of the population. So the check for the normal distribution is pretty simple. We start off with our sample size of 120 students, and then we have a sample proportion of 66 over 120, which is equal to 0.55 or 55%. First, we have to check that use the first equation to check. And what we do with that is we just multiply the sample size and sample proportion, which is equal to 66, and that's greater than 10. So that's good. And then we move on to the second equation, which is basically the other half of the sample. So we could just do 120 minus 66 here to get 54, but to practice good statistics, we have multiplied with 0.45, and then we also got 54, which is greater than 10. And our final condition is to check for the independence of the sample, and this is also relatively simple. We just set the inequality of 120 is less than or equal to 1/10 of the population of Bellarmine, which is around 1,700. And we can see that it is true that 120 is less than or equal to approximately 170. So we know that this sample is unaffected by previous or future samples.
Interpreting the confidence level. If we take many samples, 95% of the intervals would capture the true percent of people who know what the capitalist spin is. The picture that we have in the bottom right is a diagram or graph of a 95% confidence interval.
In our final calculation for the confidence interval, we should start off with a point estimate, which we can calculate by the number of successes, which is equal to 66 over the sample size. And that will give us 0.55, which is equal to our sample proportion. Generally, if we don't use a calculator, a confidence interval can be calculated by the point estimate plus or minus the margin of error, which is calculated by the critical value, which is a z-score, and the standard error of the sample. but we have a calculator, so if we use the one proportion of z interval function on TI calculators or any other calculator that has a similar function, we can see that the lower bound will be 0.46 and the upper bound will be 0.63, which means that we have a margin of error of around 0.089. So 0.46 to 0.63 would be our confidence interval.
Okay, interpreting that interval. We are 95% confident that the true value of Bellarmine students who know what the capital of Spain is between 46 and 63. The picture that we have in the bottom middle is a picture of one of our samples, people that we took our sample from. Conclusion. After taking samples from students from the different locations around campus, we discovered that 55% of the students know what the capital of Spain was, as we mentioned previously. Our sample was normal, independent, and random, which allowed us to find the confidence interval. With this information, it's reasonable to believe that 46 to 63% of Bellarmine students know what the capital of Spain is, which is Madrid. A large sample size is very important when finding out confidence intervals and taking a random sample. Our sample size was 120, which is large enough to create an accurate confidence interval for our question. By choosing our samples from different locations, our sample was more accurate and had minimal bias. If we had taken our sample from one location, there'd be a chance that the people chosen for the sample are from a class more likely to know what the capital of Spain is. One flaw for our methodology is that we took our samples at different times, so there is a chance that someone we asked our question previously told their friends who we interviewed later. Also, previously mentioned in our slide, another flaw in our methodology is that methodology is that we asked people kind of at random and we didn't have any, we picked the people and it wasn't exactly a random system of picking it. With more time and resources, we could have better randomly picked our samples and then gathered everyone into a single room and asked them our question at a similar time or at the same time, and this would completely eliminate the bias in our sample.